Now we will learn what is exception handling in Python, why we need exception handling, and how we can create our custom exception classes. Let's learn with an example. Let's say we have a function divide which takes two arguments or two parameters of integer types. And division always returns float value. So this is the return type. We can simply write x divided by y. Now let's call this function. So we will print the result as well. Print divide 10 by 2 and print divide, let's say 4 by 2. So we are printing the result of this divide method. So let's run this program. So for 10 divided by 2 we get 5.0 float value, and for 4 comma 2 we get 2, which is correct. So now what if I, instead of 2, I type 0? So 10 divided by 0. So here we get the error where in the divide function while calling 10 comma 0, then in return x divided by y we get the error. What error? The 0 division error, division by 0. So we can see here because of this statement 10 comma 0, this 4 comma 2, this statement does not get executed because we get the exception here or the error. So what if we want to execute this even if this gets failed? So here we can handle the exception. How? So in the divide function we can move this return statement in try, and we can accept the exception. Which exception? Zero division error. Zero division error. So this is an inbuilt exception class in Python, so we can directly use that as, let's say, any variable error, and we can write a print statement that we accepted the or we handled the error, or the error is handled. Okay, now let's run this program. So here error is handled is printed, and then since we are not returning anything from this function, it is by default the function returns none value. So here this statement divide 10 comma 0 returns none value, and we are printing that, so none is also printed. And then divide 4 comma 2, which is correct, so it prints the result 2.0. So now, so this is how we handle exception in try except block. So this is the variable in which we have accepted the zero division error. So ERR contains zero division error object, exception class object. So we can print that as well. So if we print this, then we can see division by 0. So this is the error that we get in the error object. So now there are few more things regarding try except. We have else part. So if this statement is executed properly, Then we move to else part. But if we get any exception in the try block in any of the statement, so except is called and else will not be called. So let's say instead of returning, we can have result equals to xy, and we can return result here, and we can print in else block. We can print in try block, and here also we can print except block. Okay, and I can add one statement here with simple dash. Let's run this program. So above this dash we have the output for this print divide 10,0. So when we call this function divide, it moved into try block and it prints in try block. So here first statement is in try block. Then it calculated the result 10 divided by 0. So this raises the exception. So we directly move out of this try block and we move to except block. And then we are checking whether we are getting this exception or not. So we are getting 0 division error. So this exception class is matched here. So that exception object is present in this error variable. Now in except block is printed. So next statement in the output is in except block. Then we are printing the error. So error is division by 0. And then it is not moving to else part because it has moved to except part. So we are not returning anything from here. So by default function returns none value. So we are printing none. So that's why none is printed in the output. Now this line is printed. Now we have called 4,2. So this function is called x is 4, y is 2. Then in try block is printed. Then return equals to x divided by y, that is 4 divided by 2, which is 2. Now result contains value 2. Since no exception is raised in try block, so it will move to else part. So that's why in else block is printed after that. And then we are returning the result, which is 2. And here we got the result as 2 and we are printing that. So 2.0 is printed because division returns the float value. So this is how we can add else block, and this is the role of else block. If exception is not raised in try block, then else part will be executed. Otherwise we will the exception part will get executed. Now there is one more thing. We have finally. We can directly write finally. So first try block is executed. If any exception is raised, then it moved to except block. Otherwise it moved to else block. And after that it moved to finally block. So let's run this program. Whether exception is raised or not, finally block will always be called at the end. So let's run this program. So here we can see for 10, 0, x is 10, y is 0. In try block is printed. Then here we raise the exception. Then exception is caught. Then in except block is printed. Then we have printed the error, which is division by 0. And then we move to final block. So finally is printed here. And then this function is completed and it returned by default none value, so none is printed here. Then for next 4,2 int try block is printed, then result is calculated as 2.0, and since there is no exception raised, it will move to else part. So in else block is printed and it returns the result 2.0. But before returning from this method, finally will always be called whether exception is raised or not. So first finally is printed and then this result gets printed due to this print statement. So this is how we can handle the exception using try, except, else, and finally. Okay. Now we will learn how to handle multiple exceptions. So currently we are accepting X and Y. Let's accept a list. List 1 is of type list. And let's say we are not returning anything. We will just print everything here. And we can remove these print statements. We can remove else and finally part as well. Okay. And now let's call divide 10, 2, and then third variable is list. So let's say we have 4 and so result 1 is x comma y. So we will print result 1 and then result 2. Let's say we are assuming that list 1 contains 2 values. So we will divide first value, so list 1 of 0 index divided by list 1 of index 1. And then we will print result 2. In except block 0 division error. Okay. Let's run this program. And since we are not returning anything, we will not print. So here we have 10 and 2. So x is 10, y is 2, and list 1 is 4, 2. So result 1 will be 10 divided by 2, which is 5.0. We are printing the result. So 5.0 is printed. Result 2 will be list 1 of 0, that is 4, divided by list 1 of 1, that is 2. So 4 divided by 2 is 2.0. So we are printing result 2 as 2.0. Since no exception is raised, that's why we have not moved to this block and we have returned from the function. So this is the program. Now what if I, instead of 2, I put 0? So this result will get failed and 0 division error will get raised. Okay. So, and this will, after this statement, line number 3, it will move to the except block and then it will print in except block 0 division error. So let's run this program. So here we get the output in except block 0 division error. What if I correct this and remove one of the item? So now list 1 contains only one item. So this statement will get executed successfully. It will print the result and then this statement will get failed. So let's check. So we got 5.0 because this and this statement, these statements are ran successfully, and we have got the error at this statement. Why? Because this is expecting list 1 should contain 2 values, but it contains only single value 4. So here we can see that we got the error. What error? Index error, list index out of range. And for this, because list 0 contains 4, so this is correct, but there is no number at index 1 in list 1. So we can accept multiple error in a single try block like this. So we can handle index error. So index error is also a built-in exception class in Python. So we can directly use that. And we can use the same variable, and we can write print except block index error. Let's run this program. So now we can see 5.0 is printed, and then in except block index error is printed. So at this statement exception is raised, and it moves the control to here. It checks whether this is accepting index error. No. Then it checks here whether this except block is accepting index error. Yes. So here in error object we get the index error object, and we have printed this statement. So that's why this in except block index error is printed. So this is how we handle multiple exceptions. So what if I don't want to write different print statements? I want to write single print statement like in except block. So how can we handle that? We can directly go to here, and we can create a tuple of exception classes that we want to handle. Okay, so we can remove this code, and we can update this line like in except block. So whether we get this error or this error, the control will come to this except block only, and the error object will be saved in err variable. So let's run this program. So here we see we did not get any error because exception is handled and in except block is printed. Now let's correct this, and let's try to get the zero division error instead of index error. Let's check with that also. So here also it prints in except block. So 5.0 is not printed because we got the exception at first line itself in the try block. So this is how we handle multiple exceptions. Now let's learn how we can create our own exception class. Let's clear this program. So we can create a class. Let's say we want to write a program which will check whether the number is even or not, or a function to add two even numbers. Okay. So for that we can have, let's say, add even numbers. So x and y. We will check if x modulus 2 equals 0, Okay, and y modulus 2 equals 0. That means both are even numbers. Then return x plus y. Okay, else we will raise exception. So this is the base exception class, and it is an inbuilt class. We can call it directly, and we can write our exception message in double quotes. So we are creating the object of exception class, and we are passing the message. Okay, so what message? Like not an even number. So this is how we have created our own exception or custom exception. So let's run this program. So first we will go with the happy flow. So we can have 2 and 6. So output should be 8. So we can print that output. Let's run this program. So here we get 8. How? We call this function. So x is 2, y is 6. So x percent 2 or x modulus 2 equals 0 means the remainder should be 0 if we divide this number by 2. So 2 divided by 2, I mean 2 is divisible by 2, therefore remainder is 0, hence it is an even number. And similarly, we have y modulus 2 equals 0. So we have added 2 plus 6. Okay. Now, what if I change it to 3? So 3 is an odd number. So now we get exception, not an even number. So this is our own custom message, which is not an even number. And this is the exception class. Okay. Now let's learn how we can create our own exception class. So we can create a class here, class not an even number. We can give any name to the class. So here I'm giving not an even number as a class, and we need to inherit the base exception class. Okay. So now we need to provide our message also. So for that we can override the constructor, which is init method. Then in self dot message, so this is a data member of this class, self dot message. We can use this message. Okay, and we can also provide some error code as well, and we can add few more variables according to our choice as well. So let's say I'm providing error any number, let's say 4245, and then we will call the init function of super class, which is our exception class, and we need to provide this message as well, because here we are creating the object of exception class, that is we are calling the init method of exception class, and we are providing a message. So here also we need to provide message. So we can use self dot message, otherwise it will not print the message. Now this is how we can create our own exception class. Now how to use that? So instead of directly using exception, we can use not an even number, and we can directly create the object of that when we want to raise. So now let's run this program. So earlier it was exception class, not an even number. Now let's run. So now exception is changed to not an even number, which is our own custom class. And here we can see not an even number, which is a message that we have sent while calling the constructor of super class, which is exception class. So this is the message that we have provided. So this is how we can create our custom exception class and use that. Now, what if I want to, let's say, handle this exception? So instead of this red or the error message, we can simply handle like, sorry, this is, we can keep as it is. We can use try block here. We can move this statement in try block. Then in except, we can handle this not an even number as E, or we can use error, and then we can print err. Before printing that, we can also print in except block. So let's run this program. So now red lines are removed, error is removed. Why? Because we have handled the exception. So program will not fail. Program will get executed completely without any error. So add even numbers 3, 6. So this method will be called 3 is not an even number. So it will move to else part where we are raising our custom exception. So now custom exception is handled here. So because this statement is in try block and it invoked the exception, so it will move to control will move to except block, and it will check whether the exception is not an even number class or not. So yes, the exception is not an even number class. So we have saved that exception object in error variable, and then we have printed in except block. So in except block is printed, and then we have printed the error object, which is this object, the exception class object. So while printing the exception class object, it prints only the message. What if I want to print the error code? So for printing the object of a class, not only the exception class, any class in Python, we can override str method, double underscore str method, and we need to return a string that we want to print. So by default it is printing or returning self.message. So what we can do, we can return error code and message both. How? We can use formatted string using F and double quotes. First we can write self dot error code, then colon, then space, and then when we can write message. So we can use the variable self dot message. We have used self. Why? Because this is a class method. First, in class method, first parameter is always self, or we can write anything else, but basically it is the object that is calling this method. And in that object, we have this data member or the variables. So we can use that using that object. So that's why self.error code and self.message. So now when we will print this object, this function will get called and it will return this string, that is error code colon message. So instead of message, we will get error code as well. Let's run this program. Now in except block, and then error, which is err colon 4245, then colon, then space, and then our complete message, which is not an even number. So using this str method, we have overridden. Basically, it is present in exception class, or Basically, in every class in Python, this method, double underscore method, which are called dunder methods. So these are already present. So we have overridden here. So this is all about the exceptions in Python.